How's everyone? Today? Was the party really good last night? Good. I didn't get to go. I was getting my demos working as usual, right? But it turns out that demos are so reliable now that they're on Azure. It only took me about 15 minutes, and I really should have gone to the party. Anyway, we'll get started in about 3 minutes or so, and we're still waiting for a few people to come by. And it seems like there's really not a whole lot of people sitting in that part or close to the front. So you're very welcome to come up to the front. I certainly wouldn't bite. And we have some interesting demos today, so it might even be better if you sit a little closer. It's a distribution, I guess. It's a distribution function, right? So I have a friend of mine who does a lot of writing on social analysis. So what they do is they have data on all the baseball games where people actually sit. So there's a very predictive way of where people actually sit every time. So anyway, we'll get started in a minute or so. And waiting for 2 o'clock. All right, 30 seconds. Counting down. All right, so as those guys are going to sit down, we're going to get started. First of all, my name is Wenming Yi. I am a research program manager at Microsoft Research, and my previous job was at the Developer Platform Evangelism. And I used to be the big data and also high-performance computing evangelist. So my new role is really to work on this new program called the Azure for Research, which is as opposed to Azure for developers. So it's really to help researchers to do very interesting programming on data. So for example, data informatics on future cities, and a lot of interesting projects that uses Windows Azure to do science. So this is my current role. So this session is really about how can developers be working on big data and still how could big data be very useful for developers for the service economy, as well as some of the scenarios that we're going to be looking at. One of the things that's interesting now is that when you, instead of writing a piece of software and ship it, and maybe interact with your customers through surveys or phone calls, you actually have very much a continuous engagement with your customers through the data that you collect in your services that you run every day. And we have some very interesting demos to show that today. So having that data and be able to analyze it will really tell you what your customers really want, as well as how you can improve your services based on the data that you collect. And the second piece that is very popular now, which is essentially what created big data, it's called behavioral analysis, or what we call collective intelligence. So the idea is to look at how humans behave in a social network or even in the content that you created for your service. So for example, Netflix, what would be the better user experience when you have the best recommendation engine for your users? So they're probably going to use your services longer. So essentially, using big data to improve your customer experience through the data that you collect and analyze. And the third thing we're going to talk about is the new frontier of big data. So at the keynote, a lot of you heard about something called Internet of Things. What that really means is that these are devices that are going to be sitting around and sending data to your cloud services or any type of services that you build. And they are not going to stop like a human being, where tweeting 100 tweets might be the maximum they could do. You could also have hundreds of devices sitting in your house. We actually have a project at Microsoft Research which we have been putting sensors in people's homes and measuring all the different effects, including when appliances get turned on, when doors get turned on and how these things affect their energy use. And when you walk into a room, turn on specific appliance, immediately in the back end, the server would be able to understand that you were in that room without even knowing. So this is through the process of doing machine learning and figuring out things that you are not really just simply humanly tagging for, but features that we can let the machine learning algorithms discover for you. Finally, I want to talk about the tools, which are essentially huge opportunities for developers. Many of the tools currently that people are using to process big data are very primitive. So they're the model called use the source and read the source and use the force, right? Use the force and read the source. So, or you will essentially have a really large team to be able to operate on these systems because they're so complex. Part of the complexity is really about the complexity of big data. So there are 4 things that defines big data. One of them is called volume. Everyone understands that. You have huge amounts of data. So in Windows Azure, we have many, many, many petabytes of data. And we have, in a world, they're reaching out to somewhere around zettabytes of data, which is 1,000 times more than an exabyte. And that's 100 times more than a petabyte. So this is so much data that people are not able to process and store all of them. There's simply, I remember that I used to use an example that everyone in China would have to hold a few dozens of disks worth of data in order to achieve somewhere around a zettabyte. So the other interesting thing here is that the speed of which the data that comes at you. So for example, Internet of Things. So if you have data that are being collected from machines, so you can't really go turn them off. Your service have to be pretty much always on. This is where the service level comes into place for cloud services and the services that you will be building, right? And there's variety and variability because the data are different. There's different formats, and you can get different data sets from different places. So getting them together essentially means you're going to have a lot of difficulties processing the data. This is why we have to invent new set of tools, which are distributed systems, to be able to process them. Going back, the first generation of applications, essentially you have these normal enterprise applications where you collect some logs and some information. That's not really a huge amount of data. And then the next version is the Web 2.0 companies. That essentially includes Facebook and all the social networks that we are talking about. So there's lots of unstructured data that we store. So these could be tweets that you have or images. They're not formatted. They're not something that we normally store in a relational database. And finally, Internet of Things, which I discussed. Those are machines that are sending data in that could in the orders of magnitude more than what we currently have. So here are some of the tools that we are trying to use to solve the problem. The first thing is that I really want to talk about the data, the importance of actually having data. So it makes a huge difference in your services if you are actually collecting your data. And for example, if the value of Facebook is really the content that they own, right? So if you don't have any data, you're not going to be able to do any type of analysis. So part of my hobby is to run a weather service that's been running for two years, and I think Nigel in the front has actually used it a little bit once. So I have, in the years, collected 50 million objects in the blob storage. And in fact, I could tell by just simply zooming in around and find out who are the people that actually log in and where they're interested in the data. And you can actually go back and find interesting weather events based on that. So there's not anything that I could have gotten from somewhere else. These are data from users that you collect. So having the data enables you to do interesting things. So if you want to do smart cars, if you want to do smart buildings, you really have to have the data. So having the data is a huge difference. So the people who don't have them won't be able to analyze them and won't be able to get ahead. Infrastructure, the new infrastructure for big data, it's always going to be distributed. If you look at all the tools, one of the traits they have is that they are all having to build large clusters of machines. So for example, at Yahoo, they have thousands of machines. There's those large Hadoop clusters. They have 36 disks in each of the nodes, and they can use them to do large processing. And the file system is also distributed, which we'll go into detail and explain what that looks like. So any type of problems that is large, we've always employed the strategy of divide and conquer. So dividing the problem into smaller pieces, and then have the smaller, and work on the smaller problems, and work on lots of them. So this is the basic principle of high-performance computing, also for big data, which many of the tools actually employ, divide and conquer. But the difficulty is that how do you divide up the problem, right? So one of the methods that we have is called MapReduce, and we're going to explain how exactly that works. And it has something that is relatively innovative. It's called moving your compute to where the data is. And it automatically partitions your data onto a large, scalable distributed system. So if you look at Azure's storage system, it by itself, distributed system, right? So it's built on top. If there's a really large load balancer in front, and there's huge amounts of big racks in the back end, right? So the storage is distributed onto many, many different machines, and each of the machines have many, many hard drives. This is how a distributed file system is built. Scalable tools, I want to talk about that, and that's really important. The most important part of building a proper or a good scalable tool is that you're not limited by a certain amount of nodes that you have. So if you have a big data tool that someone is advertising to you and says, well, my tool scales to 4 nodes exactly, that is not a trait of something that is scalable. So in order to solve really large problems, your system has to linearly scale, and to large amounts of numbers has to be designed in mostly an embarrassingly parallel fashion. Each nodes are working on a problem that is independent of each other. Finally, I want to talk about the most important aspect of big data. So there's a lot of talk about challenges in the tools and challenges of the data that needs to be processed by the hardware. But what's really important are actually the people. So there is a lack of understanding. And in fact, I had many conversations with folks at different companies as well as our partners. We really have a lack of people who are able to understand and be able to use these really distributed tools. And it's really not everyone's fault. The problem is that a lot of these tools are very difficult. So I would like to encourage all of the developers here, which many of us are actually engineering by training, to start looking at the opportunities of building better big data tools. In fact, at one of the slides that I will show you, that the current big data tools, the targeted users, they all say developers, developers, and developers. And very seldomly, they will say analyst. The reason is because scaling out your analysis is difficult. So let's talk about scenario number 1. This is about telemetry data. So in normal cases of traditional applications, we look at the log data and we might throw them away, or we don't really do very much of it because the information density is very low. And sometimes they are also called data exhausts because they're not very interesting. The data that we really cared about are actually in the database. But one of the things that has happened is that storage has become so cheap, and the big data tools that people have developed are essentially using the raw storage. So now the cost of storing your data is suddenly so much cheaper. So this is why people started thinking about maybe I could actually store much of my logs and see if I can extract some information out of it. So I've been running a little service for a while, so one of the weather services that we built. It's been running for 2 years. What I found is that data exhaust has a lot of value to it, and this is somewhat anecdotal. I deleted one of the very important tables, essentially all the weather information, all the simulations that has run for the last 2 years, and I deleted the table, and I called Azure Services and said, can I have my table back? And the guy said, no, you can't have it back. Because I said it's copied 3 over times, but if you delete it, also delete it 3 times. So it's gone. However, I was quickly able to look through all the logs that I had and recreate all the tables in less than 2 hours. And we're back in business. What it means is that even though the log density, the information density on those log files are low, you would still be able to extract information if you have the ability to process large amounts of data very quickly. So let's look at an example. So one of the companies that I've been working with is New Relic, and they are a fantastic company and a fantastic partner for Windows Azure. So they've built a tool called New Relic Insight. It's a brand new tool, and what it can do is it can look at the log data or telemetry data of any Azure services that are running. And it uses .NET injection. It's very simple. And all you have to do is there's no code writing required. And all you have to do is to enable diagnostics in your Windows Azure cloud services or web services. And all you have to do is to just enable that, and you will immediately be looking at analytics in the portal. So one of the things is that even when you have a lot of data, you probably will be trying to analyze it using Perl scripts or Python scripts. How many of you like Python to write Python scripts here? A lot of you, great. But it takes time. So what New Relic has done is that they have done the 3 most important part of collection log analysis through data collection. So they will collect all the data automatically. It goes to their server. And the second part is being able to store that data in a queryable manner. I believe it's a column-based database that they've custom built. And the third part is to be able to see the presentation in real time and be able to immediately see feedback of your services that you're running. So there's the first part is the collection. So you collect billions or maybe even trillions of lines of logs, and you store them in a schemaless large data format. And then you can present them in their portal. So part of that, if you were to build some of that yourself, it will take a little bit of time, and you have to learn the tools. But here they have already done all of that for you. So let me switch over to the demo station and show you how easy it is to be able to use that. Great. So this is an application that my colleagues at Developer Platform Evangelism has built. What it does is essentially a Twitter reader. The first thing you do is you can just simply enter the user that you're interested in, and you can press enter. And you will see that you immediately load some tweet time, or the tweets that has recently gotten. And you can see this, when I loaded it, it's pretty fast, right? And what's interesting here is I've actually hooked it up with New Relic Insight. When we originally built this application, we ran the tweets. So Twitter, if you get a free account, you get about 200 polls. And if you poll really fast, what will happen is they will throttle you. And the response time will go from somewhere between half a second to up to 10 seconds or even more. So we don't really wanted that. So what we looked at is we used the tool to look at that. So here's the portal for New Relic Insight. So on the left-hand side, you have a query section where you can immediately start writing queries. And the query looks like a SQL, essentially looks like a SQL query language, which is very much what 90% of all big data users actually use, essentially running lots and lots and lots of queries against a database that they collect. So there could be log files, it could be data that they collect from databases and try to march them up, right? So the second thing is that the data that they store. So as you can see, there's some 8 million transactions that we've collected over here. And there are also some user events that we've looked at. And finally, the dashboard. The dashboard can be custom created. And you can also create questions you want to ask your system or ask your data immediately. So normally, what I would have done is to take the log data, store it, probably run some Python script over it. If it's too much, I can't really run it on even one machine, right? And then I will probably load it into Excel. So it takes a little bit of time. But here we have a real-time dashboard. So on the left-hand side, the first one here, where we have experienced about 60,000 transactions. So this is the chart which I want you to pay attention to, which is the average external duration. So this is the time which took us to go from the service out to get a response from Twitter. Let's just say I wanted to all the tweet stats by Azure, right? So it takes about, actually at peak, you can see that, we were experimenting it, that's 6.42 seconds, right? So that's quite a long time. So what my colleague did, at DP did, is that they actually implemented something called caching. So we're just simply enabling caching in one of the roles. And instead of every time you query against the limited resources that you have, which is 2,000 times against Twitter, you simply cache and let the cache expire in 1 or 2 minutes. So for that, we're able to reduce the kind of response down to almost 0.2 seconds or almost nothing. So the telemetry data can really help you visualize. Before, you could probably figure it out, and you can probably have an idea of what these numbers are once you've looked hard. But here, once you've deployed the application, you can simply take a glance and we'll be able to see that problem, see your problem right away and be able to start working on the issues. Another interesting thing that we did was that we implemented a UI that I suggested to Nick, which is the infinite scrolling. So infinite scrolling works great on mobile, but turns out it's a terrible experience on a web browser. What happened was Nick helped me to implement that, and immediately we can see through the data that people abandoned the page almost right away because of the somewhat frustration. And we also wanted to know how many times people would actually look at scrolling, how many times people would scroll. It turns out to be about 4.75 times. So once people scrolled 4 or 5 times, they simply just say, we give up, right? So that's not very interesting. So that feature is essentially out by simply looking at it rather than trying to figure out even more metrics or interesting things. So that's my the first demo. So another thing I wanted to show you guys is that the ability to be able to run the queries from it. So one of the things that we did is that there's a little corner here, a little icon here. You can select items. You can run the query right here from the graph. And you can also we can select a max here, and you will immediately be able to change it or and have it run. So the maximum is really sitting over here. You can choose to add that to your dashboard if you want to use that metric as part of your operation, or you can just use it as a template and quickly run some queries against it. So that's my first demo, and let's go back to the slides here real quick. So one of the more important things I want to talk about here is the iterative nature of insights. So one of the things that we do, a lot of services do at Bing, so we have a large operation of developers as well as people who analyzes the data. So there's hundreds of people that essentially runs hundreds of thousands or even millions of queries each day to look at different metrics of what's happening with the services. So when you get into the habits of using data as part of your service, it's not just simply occasionally I'm going to go ask a question or so. Instead, you will have to make that into a habit. You have to continuously ask questions. You have to ask lots of them. So for example, did I misplace my UI? Where did I lose my user in this new UI design? Was it too slow? Why was it, which feature took the longest delay, and was the problem that caused the larger feature to actually fail? right? So what are the agent types? Are we having problems with the Windows users? Are we having problems with maybe Android phones? So these are the things that you will immediately be able to find, and those are the questions that you can save, and you can repeatedly ask your service to understand what's going on with your actual service. So here are some suggestions and also things that are what I consider as best practices. One is that decisions should always, you should always do data-driven decisions nowadays. Start using that as part of your development process. So every time, it's almost like a unit testing by now, right? So there should be built into your actual service. So what are the metrics that are the most important? And you should not randomly ask questions. You should ask lots of questions that actually mean something. The other part is the metrics. So how do you define your metrics? That's really, really important. So defining the correct metric, you're always going to get what you want once you define a metric, but is that actually the right thing that you wanted, right? So a lot of times metrics are actually trade-offs. So performance and cost, that's actually a trade-off. Do you want 100 VMs or do you want 50 VMs? So how do you optimize these type of operations so that you can maximize the benefit of your services? The last thing is the ask more questions and really ask questions about everything. There's a lot of times we make assumptions. Assumptions are probably some of the worst things that we can do because when you run a service, a lot of things can go wrong. So making the wrong assumptions can actually cost you a lot of time in determining what the problem actually is. So now I want to move to the second part, which is collective intelligence and predictive analysis. So that is really talking about looking at user data. So I have another very good example here. There's a company called Adixi. So what they do is they build games. And what they want to do is to monetize what these games are actually, monetize the in-app payments from these games. So some of their games are very popular. One of them is called the Space Dog, and we actually managed to get some data from one of the games that they have. It's called Labrats. So there's about 4 million users, and I got a small chunk of the data. And I can use that to explain to you how MapReduce works and show you a glimpse of how HDInsight that Azure services run, and also help you to understand how we can create virtual tables using Hive to query against data as they're sitting in the storage, rather than having to put them in a database and then do something with it. So here's a game that they built, and there's 37 levels in order to win. So the first, I believe, the first several layers are essentially, levels are essentially training data, and then the later ones are the more complex part of the games. And so what these guys wanted to find out is that where would people start actually paying for maybe special cards or gold packs, and what would be a good place where they can make the games maybe a little easier so people don't drop off exponentially after that particular game. So the way it works is that they have lots of data, and what they do is they store all that data onto Windows Azure. So they're actually one of the larger users of Windows Azure HDInsight. So that data is essentially stored in pure log files. They're comma separated. That's right, and they're comma separated files. And so one of the first things they do every day is they have a cron job, or they invoke that from a PHP script. So they run the HDInsight, they spin up a cluster, says, I want to do analysis on today's data that we've collected in the blob storage. And the next thing they do is to load up the data. So if it's really, really big, they might look at it locally. If it's small enough, they might load it into Excel or Tableau. So either one of them would work. So essentially, it's large data processing plus BI. And we're going to actually do an example. So how many of you have used MapReduce and understand how it works? OK, so I would say half of you. So we'll do a very quick review here. So the most important part of Hadoop is that it's a distributed architecture. And it has two layers on top of it. One is the distributed file system. What that does is partitions your data automatically for you. So when you put lots of data into a system, it will essentially cut them up into blocks. And you don't even know about it. It still looks like one file, but it's actually cut up into multiple blocks. So by default, it's 64 megabytes as a block. And they're copied over 3 times on 3 different machines. And on Azure Storage, which is another option of which you can run your data on, the default, what I found out, is 256 megabyte as a block. So if you want to do MapReduce on, let's just say, 2 gig files, it will probably allow you to give you a maximum way of dividing it up as, as 8 nodes. So I wouldn't spin up more than 8 nodes to be able to do the processing, because you won't be dividing it up, the work, evenly, right? So the second layer is the scheduler layer. What it does is it understands where your data is on which machine. So once it has the code, it will move that code onto where the machine is and run the computation. So I hope that I explained that relatively clear there. So using that system, you will be able to run MapReduce and distribute your workload across a cluster using both compute and also the I/O from the underlying file systems. So here's how it works. So if you have a file, so you store them onto multiple files, and they're always distributed evenly in that block size, right? Using that block size. And the next thing that happens is you actually run the MapReduce, which you take the code, which is very simple, MapReduce. You take that code and run it onto put it on each of the nodes and run the storage. So here's how they work. They have a Java MapReduce file. So my colleague, Matt Winkler, probably talked to you about C# streaming. So you can do that as well. But natively, Hadoop is implemented in Java, and a native MapReduce job is actually Java. So here's what they do. They run the MapReduce job, and they essentially do a somewhat ETL process. So they create these more refined tables or comma-separated files that you can further query against. So I'm going to actually do a demo real quick on here. There we go. So what I did is I actually logged down to the head node of the HDN site. So if you want to create a cluster, you log on to Windows Azure Portal. And the next thing you do is you just say, I want to define the size of the cluster, and you go do it simply. So here's what I'm going to do. I'm going to run this MapReduce job. Can everybody see this little line here? So essentially what I have to do is to run this MapReduce package that's sitting in the progression.jar, and the class name is called progression, and has a map and reduce file. And what I'm going to do is I'm going to just simply run that. And when it finishes, it's going to produce another file, which is more cleanly done. And for those of you who couldn't see it very well, I can actually show you that in this text pad here. So you can probably hopefully see that better. So you run Hadoop, you call Hadoop. There's probably a script, right? So Hadoop jar, and it tells you where you find that jar. So this is the progression jar. And this is a Java file that I compiled and jarred up into this file, into this container. And then that's the class. And it always has an input and output, because when you run map, you need an input. So that's all the files that's sitting in that directory. And output is the output to or whatever you have here. So once you run that, the second directory will actually have the results of it done. So let me actually go back and go to the other one. So the next piece I want to do is to take the processed file. So this MapReduce job is still running, right? But I already have another table done. So here, as you can see, that this is the syntax of what I created a table on. What's important here is that I created a virtual table. So Hive is pretty much like SQL. Instead of doing anything different, we figured that most people already understand what SQL looks like. And people have implemented this on top of MapReduce. So if you run that Hive query, it will create a virtual table and simply say, OK, well, for the column-separated files, this is what the structure looks like. And I can run MapReduce, I can run a SQL query against it, and then will be translated into MapReduce calls without you ever doing anything. So if you started using Hive, you're using big data without even having to learn anything new, and which is actually very, very important for a lot of people. So let's see. So what I'm going to do is I'm going to copy this, this query from here, which is the creating the virtual table. And I'm going to run it here. You also notice that I had a drop table there, right? So what drop table does is drops the table. But unlike a SQL table, you drop it and all your data is gone. It simply drops the structure. It drops the virtual table. It doesn't drop the actual, doesn't remove any of the files that's sitting in your blob storage. So as you can see, it takes a little bit of time. So every time you run a MapReduce job, it's a batch job. The scheduler has to figure out where everything is. It has to do some computation. It always takes 20 seconds, regardless of how large your data files are. So I used to run 10 terabytes of data, or actually not 10 terabytes, 10 gigabytes of data. It took about 14 seconds. And if you run it on across 1 gigabyte of data, it will take about the same time. So the overhead of scheduling that job really takes a long time. So I just finished that, and let's actually run a couple of queries that are interesting. So as you can see that the first query is quite simple. What I'm doing is that I'm selecting different levels from it and from the table, and I'm simply counting the event. So this is simply saying, okay, who are the people that are actually paying for at what level, and for this game ID, which is the Labyrinth, which is the actual game. So a very simple SQL query, and I'm going to go ahead and paste that in here. And always have to not forget the semicolon there. As you can see, it started to translate that into a MapReduce job, and it will start running MapReduce. And as any batch jobs, it will take about a minute or so for it to finish. So you can see that it's starting that. And if we look at the Hadoop status, there you go. So Hadoop Yarn status, there you go. So there's a couple of jobs that are running. So here's my select job, right? You can actually look at the status and see what it's actually doing. So it's a fairly simple HTML page that you can load up. So this is the first query. So now it's translating it into a MapReduce job. And it has actually one map and, let's see, one mapper and 2 reducers, I remember. It doesn't actually say here, but as I remember, it had one mapper and 2 reducers. The reason is because even though I have 4 nodes on this cluster, the file size that I had was about 300 megs, so it only partitioned into 2 different jobs. So as you can see that people bought at level 18. So they had 37 levels, I want to remind you. And they also bought at level 23 and 26 for that small partial data that I have. So another thing I wanted to point out here is that I only have partial amounts of data, which means if you don't have a lot of data, if you don't process a lot of data, you're not going to get very much out of it. So getting a small peek into a really, really large data set doesn't give you very much information. So when we ran the full set, which is, I remember, is a few gigabytes, the number increases and it gives you a much more interesting exhibition. So another query that I want to run is just showing how where people actually stop playing the game, at which levels. So here's another query that I want to run. So this is, again, for the same game. And I wanted to know that how many games were played at each level at each day, right? So once you look at it, you would say, okay, well, there's a really large drop-off at certain levels. Maybe that level is a little too hard, or maybe we could encourage the user, maybe they have suffered enough, they could buy a gold pack and to easily go through that level. So that could be some interesting things that you could do from the data that you see. So for the so most of these queries runs about between a minute and a minute and a half or so. So regardless how much data you have. So this is what we call batch jobs. I can see that this just finished. So in here, what we're looking at is that at level 13 is where it started to drop off. So if you're a program manager or you're the game designer, you want to look at level 14. What are the things that are actually stopping them from going to play the game further, right? So maybe smooth out that curve a little bit and encourage them to play the game on. And just turns out to be that a lot of people start paying for things around here, which is level 30 or 31. You can see that it really started to drop off. So there's perhaps a lot of things that you can try. If you ask me, what would you do? I don't know. But we have to try a lot of different experiments and just simply move the difficulties of different levels and maybe hint how people would probably do some in-application purchases. So I could potentially make some of these data and anonymize it and make it available so that you can play with the concept of virtual tables and be able to query against data without actually touching it in HD Insight. So let's switch back to the presentation here. So here's some of the results that they found, and it seems like a lot of people are actually buying the gold pack at level 31, and the first 8 are actually pretty simple, and what we saw in this data is that it's pretty easy until level 13, really, right? So, things have changed, so perhaps they have already changed some of this based on the data they saw previously. So, another discussion point. So what we just saw was that we ran MapReduce. And I really would call that assembly of big data language. Not very many people would be implementing that because there's a lot of coding involved. But it's very efficient. There are people still do that because they want to squeeze every little efficiency out of their cluster. And what's really most popular are Hive, Pig, and those things are easy to learn. So Pig is almost like link queries, and there's lots of people using it. Pig is where Twitter uses a lot of that, so people at Twitter invented that, and they use a lot of it. Hive, as you saw, is very simple. We've actually done some optimization. So for some of the queries that we do now in Hive is hundreds of times faster, or I remember it's 40 times faster than what we had before. There's some optimization we've done, which is some of it might be in memory, and some of it might be perhaps doing some ETL of the actual data and put them into a column-based format, which you would be able to do the table scan much faster, right? So there's a lot you can do to speed up some of these tools, which I call them as interactive. This is where 90% of all analysts and users do this. So another part is the visualization and BI tools. So I would encourage you guys to look at Power BI tools with Excel. So once you've reduced all your data into a smaller table, you can go in and simply say, hey, I want to play with the data when it's in a smaller size and more manageable fashion, right? And you can build a really pretty visualization using Power Map and Power Query. So another thing I want to talk about is very interesting, is something that we do a lot at Microsoft Research as well as at Bing. So machine learning is very important. So what we discussed here is simply looking at statistics, running queries against things. So this is about knowing what's happening now. So predictive analysis and a lot of machine learning is about predicting what's in the future, and perhaps trying to understand what would be something that I could do for the user to have a better experience. So for example, the recommendation is a classic thing that people have been using. So I remember that Eagle Nest just got bought by, it's a recommendation company that just got bought for hundreds of millions of dollars. So I actually had a data set which you can use some of these tools to plug in and load the data and just simply say, okay, what's the recommendation that I can get and play with the data set. A lot of these tools, the one I want to mention here is a Python tool called scikit-learn. It's very popular, and people use it in commercial settings. So a lot of times you talk to data scientists, they'll tell you the best way to do these models, use these models is to use scripting languages where you can quickly write up a little model and run it through and check the validity of your model, and then translate it into a much larger scale. So Mahout is one of those. Mahout is a machine learning package that's sitting on top of HDInsight or Hadoop itself. What you can do is that you can plug in your data and just simply run through the recommendation engine that they have. It would just be a one command. You just say, okay, where's your input data? What kind of recommendation would you like? And just simply run it through, and you'll be able to give you a list right away. So it's there's really not a lot of coding involved if you use a library or one of these packages that you can simply get for free. So I mentioned some of these interesting machine learning algorithms that are scalable. Some of them are scalable, actually. So k-means clustering, that's probably the first thing people ever learn about machine learning. It's about classifying things. Essentially, we're looking at many, many data points and simply say, okay, who are the groups that are close to each other, right? So that is actually a distributed algorithm. So you can run that very fast. So if you want to find patterns, so you say, I suspect there are 10 groups of different type of users in the data that I've collected. So you're going to specify, okay, I got 10. So please go find those 10 groups, and it will find that for you. So another interesting one was the restricted Boltzmann machine. That's the one that won the Netflix Challenge Prize, where they had the best recommendation engine. So in essence, it's actually something called a deep learning algorithm. So essentially, you're doing something that has many layers of hidden features that you don't even know about. So those are very interesting to look at. So if you want to learn this, learn data science, I would recommend that you start looking at these packages. And Python has really very good, Visual Studio has excellent Python support now. So you can do all of that right there inside Visual Studio with all these packages loaded. So the third scenario, which is really, really fun, and I do want to talk about, is the Internet of Things. This is what I call the new frontier of the new opportunities that exist for a lot of our developers. And also exists a lot of new challenges, because the services that you'll be running that will be talking to these machines are going to be very different from how your users would interact with your services. So here are some of the challenges, right? So the first thing I could think of is the fact that people are going to have multiple sensors sitting in their home. So your devices will be interacting with other devices through the cloud. So those are the kind of opportunities that you will be finding. And also anywhere at any time, right? So there's going to be sensors pretty much anywhere we go, right? It'll be in your home, it'll be at work. We'll have some examples of what Microsoft is doing with trying to reduce energy uses with some of our larger sensors. And also ubiquitous access without user, as I said. They're not going to be people who have very limited amount of interaction with your services. They're always going to be interacting with your services in a continuous fashion, and that would be certainly a lot more challenging than what we had before, the current services we were running. So here's an example that I want to show you. This is something called 88 Acres. It's a project that Microsoft runs, which they have automated all the data collection for all the buildings around Puget Sound, and also Puget Sound area, which is 88 acres. We have about 60,000 employees or 50,000 employees. So as you can see that on a weekend, there's not much. There's still some people working there, but not a lot, right? So not a lot. But there's normally during the week, Monday you have a lot of use, and Tuesday a little bit lower. So there's a lot of patterns that you can find about your energy use. There's money involved in that, because if your peak exceeds certain level, you'll be fined for having to pay for a lot more money, because you may have blown out some generators in somewhere, right? So another interesting thing I saw is that when people go to lunch each time of the week, right? So you can see that they're not quite the same. You see that on Monday, everybody kind of goes to lunch at the same time. And then Tuesday, it's a little bit different. And you can certainly zoom in and look at it. And you wonder what this is, right? So this is I'm guessing, actually, maintenance crew, coming in, right? And also some of the HVAC that gets turned on at night to reduce energy use. So I want to talk about some of the tools that you have to start looking at for dealing with streaming data. So streaming data is very different from simply putting some files in a blob storage and say, hey, I will analyze it later, right? So streaming data is that, well, if you don't get it now, it's gone. So I'm sending you all this data. You have to keep the services running. So luckily, someone has already invented a lot of interesting tools. So Storm is one of them. It's a distributed streaming tool set. Like I said, any big data tools involves being a distributed design. So the other interesting thing is that guaranteed data processing. What it really means is that if it didn't quite process your data, it would drop it and it would try it again. So essentially a replay. And it's horizontally scalable and fault tolerant. I remember that someone at Twitter actually showed an example of running the live service. Oh, this is Twitter running, and I'm going to turn off a machine. And he turns off the machine. And all the other machines start taking over. So it's something that people have been running in operations for a long time. And you also notice that a lot of big data tools comes out of operations. It's very different from just saying, I'm going to go write a piece of software anymore. It's not true anymore. So people use it in their daily operation. They've used it and tested it and has proven that it worked. And for the rest of us, we should really take advantage of the fact that someone have pulled out their own hair instead of having pulled out our own to build these very complex, large distributed systems. So let's actually take a look at how it works. So in the system, you have these tuples. Tuples is essentially objects that are passing through the system. So what I call these systems is DAGs or direct graphs, essentially. So the tuples are flowing through the system, and each of the processor can do interesting things to it. So these consist of topologies. They're called spouts and bolts. Spouts are the ones that are emitting things, and bolts are the ones that are doing the processing. So the bolts, you could do you have to implement that yourself. You can do very interesting things with it. I could be taking a bolt and say, I want to store stuff in a storage. I can take a bolt and say, I want to aggregate all the numbers. I can have another one that does something else. As you can see, it's very similar to worker role, web role. See that? Distributed systems are things that you can increase the scale of each individual type of instances. You just have to implement them once, and they can scale out for you. Okay, so here's the architecture. As you can see that the streams come through, the bolts process them, and you eventually go to the end. When it's all successful, it's done. Right? So if there's something that happens, you can roll them back if you needed to. So we're going to show a demo. It sounds actually something really, really fun. Let me switch over to my machine here. Hopefully it's still working. Yeah, there you go. So this is this is a really fun project that I was working on last week. What's interesting about this is that we're using Storm, and we're also using another piece of software called Kafka. And what this does is that I have some data that I got from, let's just say, some colleagues that they got out of their vehicles. So it's essentially a continuous stream of GPS data, RPM data, and temperature data of their engines. So what I did is I created a little client. So this client is essentially a Kafka client or the messaging client. So Kafka is a distributed messaging. It's an Apache project as well. It's a distributed messaging system. It's very similar to Service Bus. So the idea is that you have a load balancer in the front. You can send it as many messages as you want, and it will be able to persist those messages. It's not going to get lost. It also has the sub-pub model, as some of you know. So the idea is that I'm sending my data into that messaging service. And Then there's another cluster that happens, is the storm cluster. So the storm cluster is the one that does all the processing, as you saw earlier. And part of the job was storing something in the database, and part of the job was to actually aggregate all of these numbers. As you can see, these numbers are all aggregated. So one of my favorite chart item is the donut chart. It seems like everyone starts using that chart right now. It's a donut chart. It's actually the gear ratio. What it does is it aggregates all the time that your gear has shifted and look at the ratio of all of them. So let's just say if you have 100 data points that are in gear 1, it will be showing it as a ratio. And then there's the temperature gauge. Then there's the RPM, and there's also a little real-time, time series data that it's being shown. And I also send the GPS data onto here. Anybody recognize where that is? Central Park. So I said we'll take a drive in the park, right? So what's interesting here, let me show you what the services looks like. So very quickly, that is. So the first thing is that you can see that here's the Kafka backend. So it's actually this is a Storm processor, which is taking the data from the messaging service and processing it, right? So here's another window where I'm actually sending the data in for it to be processed. And then I have a web server that pretty much displays what this looks like. Let's see. So that's enough fun. Let me actually go back to the slides here. As you can see that I actually have a really fun video for you guys to see. So Internet of Lost Things and Internet of Sharks. So the reason I call it Internet of Lost Things is that how do I play that now? Can I play this? I like to actually play it. OK, I know what we can do. We can go in here and play it from here so you guys can see it. Switch to over here. So this is the taxi data that someone gave me, which has 50,000 taxis that are running around in the city in Wuhan, somewhere in China. And the visualization for 50 taxis becomes extremely challenging. So what I did is that I did a partial selection of the taxis that I can show. And you can really see that it's very interesting how the taxis actually move in the middle of the night. So this is between midnight and 8 a.m. The reason I call it the Internet of Lost Things is that I recently lost some items in a taxi and was able to find it back because of the fact that they now actually track all the GPS items. And my phone actually uploaded pictures because the person accidentally started snapping pictures. So as you can see, it's actually quite interesting. I also have some shark data. It's Mako shark migration. So a lot of animals actually start having these tags that can do transmission. So you can see what happens. This is a shark migration. You can see they have a lot bigger range than humans do. They can really, they're very powerful animals, right? Until you be able to see that. So there are some projects that can real-time track animals and also in the safaris and some other places. And some of those projects are in our Azure for Research program. So as you can see, there's a lot of interesting things you can do with the GPS data that you have. Or any other types of data, right? So let me go back. Well, I don't know why it didn't play. So here are some of the tools. One of the most important thing of why people started using big data tools and why you should also is that it really made the cost of dealing with data much cheaper. And I like to call it the cost of reducing, reducing the cost of curiosity, which you're trying to find something from the data set and it's suddenly becoming so much cheaper and making it possible at all, right? So let me talk about the batch processing. The batch processing is really MapReduce. It takes a long time to do your processing. So a lot of people don't do it unless you have, but you can process huge amounts of data. So you run that as a batch job every night. And then you can also have interactive analysis, which is 90% of all the people that do this. Turns out that 90% of all the jobs are less than 16 gigabytes worth of data that people are querying, even in a big data setting. So, and then finally, the streaming data format, which is the a way that you can continuously process things that are coming in. And I also showed you how the tool actually works today, right? And you can see, I found that all these tools require developers. So big data needs you, as much as you need big data, right? And finally, I have 3 very simple things to summarize, or for you to start looking at. One is that discover the potential of your data. So until you start looking at your data, you don't really know what value you have. And sometimes the data is very, very valuable, and it's also time sensitive. So you certainly wouldn't want your stock data from 3 months ago, but you prefer to have it tomorrow's data, right? And call Australia, right? Let's see. So I also start experimenting, asking better questions and asking lots of them. And I also like to have all of us start looking at how we can explore the opportunities of Internet of Things, where operations will yet again demand new tools and new talent. And I have some references for you. So we have a lot of tutorials on windowsazure.com about HDInsight. So the tutorials are so well done that I highly recommend that you look at it. And you can also follow me on Twitter or tweet to me if you have any questions. And finally, this is where I live, which is, I think I have a typo there, but www.azureforresearch.com. And I will make these samples available to you in the very near future. So just look at my tweets or send me an email or tweet if you would like to have these samples for your own use. And your feedback is important, and we really appreciate that if you fill out the survey. And once again, thank you very much for staying through the last session of last day. And have a very safe journey home. I hope you had a good time at Build. Thank you.